A university has determined that the probability that a new student with confirmed, say, residence space assignment will actually take the assignment is 0.91. So what we are assuming here is that the probability that any of these students will take that assignment is 0.91, and the university has 1000 spaces for new students for the residence halls. Now the university would like to confirm the assignments to more than 1000 students so that the spaces are not wasted. Now they want to do this overbooking in a cautious manner so that the probability of them running in trouble is no more than 0.01. So let's see one way of approximating such a probability. So we would like the probability that x is greater than 1000 is less than 0.01, which is the same as 1 minus the probability of the complement, that is x is less than or equal to 1000, or in other words 1 minus the cumulative probability of 1000. So of course this is a scenario in which we want to do probability calculation, and it's very hard to match the condition of a model really ideally. But in here, let's say we apply the binomial model under the assumption that the probability that any student will take the assignment is 0.91. All the students are making their decisions independently. So what do we want here is that we want to find the largest possible n to fit this scenario for our binomial model. In other words, what we want to do is that we want to see that how many students, of course, the number larger than 1000, can we confirm the assignments to, so that the probability of having an undesirable situation is no more than 0.01. So what we do is, let's go to Excel, and here we want to go for more than 1000 students. So 1001 is more than 1000, right? So we will just go ahead and explore, like, how many can we go with. So here is the number, right? Now what we want to do is that we would like to, let's insert function, and we want to do binomial, right? So number of successes is 1000. Now the total number of trials we are going excuse me, we are going to keep that as variable in this case, because that's the number that we want to determine, and the probability of a success in any trial is how much? 0.91, and we are going to say true for cumulative. Okay, so what we have here is right here we have this probability, the cumulative probability, and we are looking for what? We are looking for the probability of the complement. So we put the equal sign, then 1 minus, then we press enter here, and of course this is 0, but confirming only 1001 people may not be that big a business reward. So here, if you go with that, let me just do this here, bring it over here, okay, and so that we can see this in a little larger situation. So notice this, that here even up to 1044 the probability of running into trouble is pretty small, like it's about 1.2 out of 10,000 or 1.3 out of 10,000. So we hit our 0.01 situation. Let's see where we hit it, right here, right? Okay, that is if we go ahead and confirm 1076 people, then the probability that more than 1000 of them will show up is how much? 0.0096. 0.61 approximately. And if we go one more, then it exceeds 0.01 slightly. So we can advise them to go up to how much? About 1076. But make sure that if you use a model, you have the conditions for the model met here.